Here we have your graph book. This is your graph page. This is what you'll be using in writing your exams. I don't want to use the graph board so that you now say that, hey, she used graph board, that's why she's getting it correctly. I'm going to teach you using this. Now, you notice the lines running down. The lines running down are your vertical lines. And then the lines running across. The lines running across are the horizontal lines. Now, watch. You now notice that between one thick line and another thick line, you have 10 smaller boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 smaller boxes. 10 boxes. And then when you now notice, you now also notice the between this thick line and this thick line, you also have 10 smaller boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these 10 smaller boxes, they represent 2 cm. While 5, 1, 2, 3, 4, 5 represents 1 cm. Here also you have 1, 2, 3, 4, 5. 5 will also represent 1 cm. Alright? Now the next thing is your choosing of your scale. You can use 2 cm to represent any unit at all. And the choosing of your scale, remember, you will be using in multiples. You use 1, 2, 5, 10, 15, 20, and so on. Then in submultiples, you have to use 0.1, 0.2, 0.5. You can use 0.02. You can use 0.05. Alright? Then you will start by saying let 2 cm represents maybe 1 on the vertical axis, and 2 cm represents 5 on the horizontal axis. To understand this, let's use our earlier equation to plot the graph. We used our earlier equation we got in the other video to plot graph so that you understand it perfectly well. The first thing, this is the values we have. From these values, the first thing you do is to get your margin. This last line is not part of your margin. The margin is either you move 1 cm inside or 2 cm inside. Now, I want us to move 2 cm inside. Let us move 2 cm inside in this. Then, this is our vertical axis. Now, our horizontal axis, let us move. You can move 2 cm inside or 4 cm. You can either go 6 cm. Looking at our values, let's move this 6 cm inside. Let's move 6 cm inside, or 4. Let's make it 4 cm, so that we'll be able to spread it very well. You drop this is our horizontal axis. Alright, now we have x, so this is our x axis. You put arrow to define it. Then this is our y axis. Put to define your axis. We have defined our axis. Remember, you must start from 0 origin. So 0, 0, showing us that we are starting from 0 origin. The next thing now is we look at our values to know the values we will apportion to our axis. The scales that we use now. Now, this is our y axis. This is y. And we have between 5 and 15. So we want to pick a value, a scale, or pick the value or unit that will give us the best form of graph that we want. So looking at this, we can now say, if we say let 2cm represent 2 units, you now have 2, 4, 6, 8, 10. 2, 4, 6, 8. So we can now say let 2cm, we can say let 2cm represents 2 units on y-axis. So what are we saying? Now say every 2cm you have 2. Another 2cm we have 2. This is now 4. Another cm we have 2, 6. This is 8. This is 10. This is 12. This is 14. This is 16. Can leave it there because that covered our values. Then on the x-axis, we now say we have 1, 2, 3, 4, 5, 6. So we can now say and 2cm represents 1 unit on x-axis. So if we come here, we say this is 2cm, this is 1, another 2cm is 1, which is 2, 3, just be adding the 1, 4, 5, 6, 7, 8. We have our values. We now plot. When x is 1, y is 5. Now, how do you know what will be in between? You will now do this. You will now say if 10 boxes is equal to 2cm, what will one box be? One box will be what? You can now call it this x. So you now have 10x is equal to 2. Therefore, x is now equal to 2 all over 10. So when you divide this, you are now having point. Then you now have 0.2. You have 0.2 because you put 0 here. 10 into 20 is what? 2. So we have 0.2. So here each line, the smallest division here is giving us 0.2. So if this is 0.2, 0.4, 0.6, 0.8, this is 1, 1.2, 1.3, 1.4, 1. This is 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4, 1.6, 1.8, this is 2, 2.2, 2.4, 2.3, 2.2, 2.4, 2.6, 2.8, this is 3. The same thing if this is 4, 4.2, 4.4, 4.6, 4.8, here is 5. So we now have our 5 here. So when x is 1, y is 5. This is x1. You now take it up. You take it up to meet y. So here is 5. You drop. Alright. Now, when x is 2, y is 7. This is 6, 6.2, 6.4, 6.6, 6.8. This is 7. So the 7 is here. When x is 3, y is 9. This is 8. The same thing. 9 is here. When x is 4, y is 11. This is 10. 1, 2, 3, 4, 5. The fifth line is the 11. When X is 5, y is 13. So this is 0.2, 0.4, 0.6, 0.8. This is the 13. And then when x is 6, y is 15. This is line 14. 1, 2, 3, 4, 5. This is the 15 is here. We now have our points plotted. The next thing is to draw your line of best fit. Your line of best fit. In drawing your line of best fit, you put your ruler and make sure the whole, either the whole points we enter or the points that did not enter, the ones that are on your right hand side, must be equal. That is the number of points that did not enter the line that will be on the right hand side must be equal to the number of lines that did not enter that will be on this left hand side. Or the deviations from the line, when you calculate them, it must be equal to 0. It must be able to cancel out. Then that way you now know that you have gotten your line of best fit. But in this our case, look at it, all the points are entering. So they have entered, then you now draw. This is our line of best fit. This is our line of best fit. Then the next thing is for you to now calculate your slope. Your slope must be large right angled triangle. We put our slope this way. We can make it this way. We can do it from this point to this point. You can make it this way. So this is changing y-axis and here is changing x-axis. Then we have to calculate our slope. For you to calculate your slope, you now write slope. You must put the formula changing y all over changing x, and this is equal to. So change in y here is, we started here. Here is 15. 15 minus here is 5. 15 minus 5 all over, you have here 6. 6 minus, you take it here, 6 minus 1. 6 minus 1. And this is 10 all over 5. You cancel. This will give you what? 2. Our slope is 2. Now, you notice that there is intercept on the y-axis. There is intercept on the y-axis. So you have to look at where in this your line of best fit cuts your vertical line, the vertical axis or the y-axis. Here, see, this is 2. You have 2.2, 2.4, 2.6, 2.8. You have here now 3. This is 3. 2. We also started 2.4, 2.2, 2.4, 2.6, 2.8. Here will be 3. So it has cut this line here. The intercept is 3. Let us now, so you now have that the intercept is equal to 3. Now this is the equation we used, we plotted. And from our graph, we have that the intercept is 3, which is good. And then we have that our slope is 2. And this is exactly equal to the equation of a straight line graph. Equation of a straight line graph, which says that y is equal to mx plus c. So we have been able to prove this. Now